Now we've looked at the hydrogen fuel cell, I'm going to look at the future of hydrogen, and we'll discuss the development of fuel cell vehicles, FCVs for short, and then we'll look at the advantages and disadvantages of using hydrogen or hydrogen-rich fuels as fuels for the future. So we'll start with the development of FCVs, fuel cell vehicles. So these are vehicles that use hydrogen or hydrogen-rich fuels in the fuel cell. And an example, or a couple of examples of hydrogen-rich fuels are methanol and methane. You've already seen the hydrogen fuel cell, so you know hopefully from the previous video how that fuel cell works. We'll just spend a little bit of time looking at the methanol example. The first example we're going to look at is where the methanol is converted to hydrogen on board the vehicle. So you can see that red equation there. On board the vehicle in something called a reformer, the methanol is combined with water and produces hydrogen and carbon dioxide. So the hydrogen that's formed would then be fed into the fuel cell in exactly this, and that would run in exactly the same way as a hydrogen fuel cell. The beauty about methanol is it's a renewable substance because it can be generated from biomass. The other advantage of methanol over hydrogen as the actual fuel at the start of the process, methanol is a liquid, and liquids are far more easy to store than something like hydrogen gas. Hydrogen gas has got to be stored under very, very high pressures, very, very low temperatures, and that's problematic. Whereas a liquid fuel, much easier to store. The second example is when the vehicle fuel cell uses the methanol fuel directly. So it's not converted to hydrogen on board the vehicle, it's actually used as a direct fuel. So the way we would process how that works is we would need the two half equations for the two half cells involved in the fuel cell. You can see I've written up the two equations, half equations there, and all I'm going to give you information wise is the fact that the methanol, the one that includes methanol, is less positive than the one including the oxygen. So from that information we can see that the most positive one, so the oxygen one, will move in the forwards direction, therefore this one will run in reverse. To get the electrons to cancel out, I've multiplied the bottom one by 1.5, 3/2. That's going to take my electrons in this equation up to 6, so they will cancel with this one when they're combined. So the overall equation starts out looking like this. We've got 3/2 oxygens, 6H plus, 6E minus. They will combine with these. Remember, this is going backwards, so there they are there. Going to produce 3/2 times 2, so 3 waters, and then all of these 6 CO2s, 6H plus and 6E minus. So now we can cancel, and so the 6H pluses can disappear, as can the 6 electrons, and we've got 1 water there, and we're left with 2 waters there. And you can see that's going to give us this equation here. I'm going to use the blue equation now to think about an advantage straight away of the methanol fuel cell over a conventional petrol engine. So we've got octane here, which is what a petrol engine would use. There's the combustion equation for petrol or octane, and hopefully you can appreciate that we're getting far less CO2 from the methanol fuel cell compared to the conventional fossil fuel petrol engine. So that's got to be an advantage of a methanol fuel cell. So there in green we've got some advantages. I've already mentioned the first one. Less carbon dioxide comes from a methanol fuel cell compared to a conventional fossil fuel engine. So in this case I've used octane. You could use diesel, which typically has 15 carbons. So that's going to give even more CO2. The other advantage you could say is methanol is a renewable fuel because it's obtained from biomass, whereas fossil fuels are finite. And then a final sort of more generic advantage of fuel cells over conventional fossil fuel engines is the one at the bottom there. Conventional fossil fuel engines, or petrol engines, typically are around about 20% efficient. So if you think about all that stored energy in the fuel, only 20% is actually converted to do useful work. In other words, move the car. Most of the energy is wasted as heat or lost as heat. Whereas fuel cells are typically in the range of 40 to 60% efficient. So it's all looking absolutely brilliant for the future. Hydrogen fuel cells or hydrogen-rich fuel cells are going to save the day, but they do have some disadvantages. So I'm going to run through those now. And the first of these is the fact that hydrogen gas is very, very difficult to transport. And I'll elaborate on that in a moment. And the main reason for this difficulty in transport of hydrogen is the fact that it's very difficult to store. So how is hydrogen stored? Well, one of the methods is as a liquid under pressure. That would be at a very, very low temperature. So if you imagine you've got to keep the hydrogen below its boiling point, you can see in red there, the boiling point of hydrogen is minus 252.9 degrees Celsius. Imagine the thermos flask that would have to be in, the hydrogen would have to be in to stop it from boiling. So huge flask, very, very thick walls. It's going to be very, very problematic. A second way to store hydrogen is to adsorb it onto the surface of a solid material. So this is the solid material here, and these red double circles represent the hydrogen, and you can see there that it's on the surface of the material, and then it can be released when required. The third method that can use to store the hydrogen is it can be absorbed within a solid material. And the way that works is the hydrogen gas, so these red molecules here, they dissociate into individual hydrogen atoms. So H2 will dissociate into two H atoms and then enter the material, so absorbed within the material. So you can see these individual red circles, and then that would diffuse back out again and reform the H2 molecules, and then it can be fed into the fuel cell. So we've discussed the problem with method 1, where you have this huge, very thick thermos flask to keep the hydrogen below its boiling point. The problem with the adsorption and absorption methods is in the fact that these only have a very limited lifespan, and so they would have to be replaced quite often. And these spent absorbers and adsorbers are going to need to be disposed of, and there are obviously environmental issues with that. If you think about a conventional car, how many times have I had to replace a petrol tank in the quite a few years I've been driving now? And the answer is never. And then another reason is the fact that fuel cells have a limited lifespan, as well as the absorbers and adsorbers in the storage. The actual fuel cells themselves have limited lifespan, and so they're going to need to be replaced, and the spent ones are going to need to be recycled, disposed of. Again, environmental issues there. The fourth disadvantage is the fact that fuel cells use toxic chemicals in their production. So that's not great. There is no hydrogen infrastructure. So what do we mean by that? There's no network to transport and store and serve hydrogen as a fuel. So if you think, where's your nearest hydrogen fuel station? Probably isn't one. And then the final one is, where do we get this hydrogen from? We don't just get hydrogen out of the air. We need to manufacture it first. And where would we get the hydrogen from? We could get it from the electrolysis of water or from the reforming of methane, and they both require energy. So the energy required to make the hydrogen, is that going to counteract the benefits that we get from using the hydrogen with it only giving its water as its byproduct? I just wanted to finish by mentioning some other good videos that I've used in my own lessons that I've found on YouTube about this. They do a good job in bringing this topic to life. They're all about this car called the Honda FCX Clarity, and so there's the official Honda video. Top Gear have done a feature on it, and so have Fifth Gear. If you're a fan of Top Gear, there's one about a motorbike as well, which you might find interesting.